Good morning, good afternoon, or good evening. This is going to be a full paper work through of Paper 3, A Level, June 24. As with all of these, it is very important that you have had a full attempt yourself. Looking at a mark scheme or someone else's solutions loses the large majority of the value of that paper. It's much more valuable for you to have found the solutions yourself, or at least got stuck yourself before looking at someone else's solutions and hints to guide you through. As always, this is a relatively blind work through. I have looked at the paper already, but I haven't worked through any separately, so hopefully you'll see a lot of the first thoughts and ideas that go towards a strong attempt at papers such as these. Without any further ado, let's get started with question 1. Each of these series form a geometric. Identify the only one which is convergent. So convergent means if you keep going forever, you'll eventually tend towards a fixed value, and in particular you need the common ratio to be strictly less than 1, the modulus of. So the first one, the common ratio, is 2. The terms are getting bigger, that sum isn't going to converge. The second one's a really odd one, has r is -1, and that sum actually alternates between 1 and 0, but doesn't converge. It doesn't get close to 1 value. This one has r is -1/2, and if we're using the condition that the modulus of r needs to be less than 1, that one does converge. And the final one had r equals 2 again. We're doubling every time. That one is not going to converge. The terms keep getting bigger and bigger. So it's actually the third one, even though it started as the biggest. That quadratic has a repeated root. Repeated root means that b squared minus 4ac is 0. So b squared is not 36. Is 4 times 4 times 9, which is 144. So b is plus or minus 12. One of the graphs below cannot have that equation where a is positive. So if a is positive, well, that actually does make a difference. If a is less than 1, it's going to be a decay. We have something less than 1 raised to a power that gets smaller and smaller. If a is bigger than 1, then we have a growth. So that's the first two options. If a equals 1, 1 to any power is the same, so that's that one. So the only one that's not possible is there. We cannot have a positive number to a power ending up being negative, in this case being below the x-axis. Question 4. The curve has an equation, find the derivative. So the first term is super simple. The second is a statement that you should just learn. A to the x differentiates to ln a to the x. Question 5. The diagram shows a sector. The chord divides the sector into a triangle and a segment. The angle is pi by 6, and the radius is 18. Show that the area of the shaded segment is that. Well, the shaded segment is the area of the sector, subtract the triangle. So let's work both of those out. The area of the sector is a half theta r squared. So that's a half of pi by 6 times 18 squared, which comes out as 27 pi. The triangle is a half AB sine c, sine theta, which is a half times 18 times 18 times sine of pi by 6. Now I need to make sure there that your calculator is in radians, is 81 pi, which is a little concerning because the segment is 1 divided by the other. 1 subtract the other, and up here I've got that subtraction the wrong way round. So I'm just going to check my numbers. Oh, it's not 81 pi. I put the pi back in for no reason. It's just 81, which is what my calculator told me. I just put an extra pi by habit. So the segment is the sector minus the triangle is 27 pi minus 81. That's got a common factor of 27, pi minus 3, which is exactly the form that the question wanted it in, with k as 27. Carrying on, question 6, we have an integral. So the first thing I want to do to this integral is to write it in an integrable format, and that's by rewriting the 1 over root x as x to the negative 1/2. And now I can integrate it, increase the powers, divide by the new power, increase the power, so here the power goes to 1/2, divided by 1/2 is the same as doubling, remembering the plus c. The gradient is given by this function, which is the same as the integral we've already done, and it goes through 490. So part A of the question has told us that y is the answer to the previous part, 2x cubed minus 10x to the 1/2 plus c, and now we can try and find that plus c by using the initial condition given. So y is 90. The x is 4, which is quite nice. 4 is a square number. We've got a power 1/2 going on. Working out the number side, minus 10 times the square root of 4 is 108 plus c. So c is negative 18. We wanted the equation of the curve, so I'm going to write the equation of the curve. And you could check by subbing 4 into the left-hand side, sorry, the right-hand side, and getting the 90 that I expected. Question 7. The graph with those equations are shown. We've got a negative quadratic and a linear line. They intersect at A and B. On the diagram above, shade and label the region. So y is bigger than 0, but it's below the curve, and the x plus y is greater than or equal to 1. So that means I'm going to have to be below the curve, above the x-axis, because y is positive, and then the x plus y being greater than 1 tells me I'm above the x plus 1, y equals 1 line. Now I'm half expecting it to find the area eventually. No, we're not going to be asked to find the area of that region. We just want to find the coordinates of A. We just want to find where these two curves intersect. So we have that x plus y equals 1. We also know that y is the quadratic. 2 plus 3x minus 2x squared. So putting those together, substituting the y into the equation above, and that's a quadratic. I'm going to make it look like a quadratic. I like my quadratics to be positive x squareds. So I'm going to put 2x squared on the right. I've got 4x on the left, which becomes minus 4x minus 1. Now it's already hinted by finding the exact coordinates of A that this isn't going to give me nice numbers. Doesn't look like I factorize it, which kind of doubles down on that evidence. So using the quadratic formula, negative b plus or minus the square root of b squared minus 4ac. 4ac is negative 8 all over 2a. So it's going to be 1 plus or minus, well, root 24 is 2 root 6. That's a half root 6. Now at A, my x coordinate is negative, is less than 0. So our x that we're going to use is 1 minus a half root 6, which you can check is negative. And then y equals, well, we know that x plus y equals 1, so y would have to be a half root 6. So the x plus y equals 1. And that appears to be roughly correct. A has got a positive y coordinate. It is on the left-hand side of my picture. It does have a negative x coordinate. Doesn't look like the x and y coordinates of A and B are symmetric. But then again, our solutions are symmetric. They're symmetric around 1. We're adding a bit to 1 and subtracting a bit from 1. And if we do look where what 1 roughly is, yeah, they look a little more symmetric. Actually, 1's here, because we know x plus y equals 1 crosses at 1. And yes, A and B are symmetric about that point. So that answer is incredibly reasonable. Of course, we should actually write the answer how they want. They wanted the coordinates, so let's make it very clear. We found an x and y, let's make it clear that they are to be interpreted as coordinates. Question 8. The temperature of an oven is modelled by that. Initially it's at room temp. The maximum temperature is T. Temperature is predicted by that graph. So room temp is initial, so that's when T equals 0. Theta is 20, 11 minus, well, e to the power of 0 is just 1. So room temp in this model is 20 degrees. Carrying on, find the value of T. Well, T was the maximum temperature. So as T goes to infinity, we tend towards the maximum temperature of the oven. But the thing to notice that e to the negative kt goes to 0. So therefore, capital T is 20 lots of 11 minus 0, or 10 times 0. So the maximum temperature oven is 220. And if you know anything about ovens, that's a reasonable maximum temperature. If it came out as 2000, you probably should be worried. You should probably get your oven checked out. Part C. The oven reaches a temperature of 86 1 minute after it's turned on. So now we're going to finally try and find the value of K. So our temperature, and I've forgotten what the model looks like, theta 20 minus 11. Theta equals 20, 11 minus 10 e to the negative kt. So when t equals 1, theta is 86. So let's try and solve that. The only unknown now is that k. Maybe the easiest way is to divide by 20 first. Of course, there's lots of different ways to tackle a question like this. I'm going to move the 10 to the e negative k to one side and put the 4.3 on the other, giving me 6.7. So e to the negative k is 0.67. So k is negative ln of 0.67. That's my exact value. Question didn't tell me about exact or not, so I am going to give the answer to probably 3 sig figures. Well, it comes out as 0.4004. So I'm going to just quote it as 0.4 to 1 dp. And notice I've given the examiner there 3 choices of a correct answer to give me the mark for. It's a good habit to have a little bit of redundancy, certainly when there's rounding involved. Find the time taken for the temperature of the oven to be within 1 degree of its maximum. So its maximum was 220, so we now want to try and find 219. And I'm going to leave this as k up here and use the answer button in my calculator eventually, or the exact value more likely. So solving that, again, let's divide by 20. 10.95 equals, let's do that same swap, e to the negative kt equals 0.05. So e to the negative kt is 0.005. So negative kt equals ln of 0.05. So t is equal to ln of 0.005 divided by negative ln 0.67. Ln of 0.05 divided by negative ln. Have I got a sign wrong somewhere? I might have. Because that's giving me a time of negative 13. So somewhere I've made a sign error. So let's look back. Divided through there. It is 11 minus 10, wasn't it? Yep. Within 1 degree is 219. Oh, because it's negative k I'm dividing by. So that's a negative negative. K was negative ln. So negative k is positive. Okay, so my answer is 13.229. Find the time taken. Again, I'm giving them a overly detailed answer. So it's 13.2. Let's check the context. T is in minutes. So 13.2 minutes. And let's just tell them what I rounded it to 3 sig fig. So if you're baking or cooking and you need your oven at basically 220, it'll take you about 13 minutes to get very, very close as a preheat. Question 9. We have a circle. The center of the circle is P and it intersects the y-axis at Q. The equation of the circle is that. Express it in that form. So we've got to complete the square going on. So first thing I'm going to do is put the useful things on the same side, equals negative 27. And let's complete the square. So that's going to be x plus 4 squared minus 4 squared plus y minus 6 squared minus off the 6 squared. And then finally clean things up, send everything, or at least all the numbers, to the right hand side. Negative 27 plus the 36 plus the 16 gives 25. That's very promising because 25 is a square number. We know that the end is an r squared. Perfect. Part B, state the coordinates of P. Well, P was the center, which is the A comma B is negative 4 comma 6. Find the y coordinate of Q. Well, Q is when x equals 0, which means 4 squared equals, or 4 squared plus y minus 6 squared equals 25. So y minus 6 squared is equal to 25 minus 16 is 9. Y minus 6 is 3 or negative 3, so y is 9 or 3. We have a choice, but because of the picture, Q is the one that's higher up. So let's use the y equals 9, so Q, yeah, we wanted the y coordinate is 9. Question part D. The line segment QR is a tangent, okay? The point R has coordinates 9, negative 3. I'm also going to label on all the other coordinates that I know, just as I'm expecting that to be useful. Find the angle QPR. So I'm looking for this angle here. Well, it's a right angle triangle because we were a radius and a tangent. So this implies we should be using a bit of trig. Well, trig needs side lengths, so let's work out some side lengths. So let's find out the length of QR. I'm going to work out the length of QR squared, which is the difference in the x coordinate squareds plus the difference in the y coordinate squareds 9 squared plus 12 squared. That's another Pythagorean triple. That's 225. So modulus of QR, the length of the line segment QR is 15. Let's do the same. Probably QP is the easiest to find, mostly because Q has a 0 in it. So that's going to be a 4 squared plus 3 squared, another Pythagorean triple. So QP is 5. Now, if we did work out PR, PR would not be a nice number. That'll have some square root in it. And then finally, the angle, let's call it theta. I've now got the opposite and the adjacent. So tan theta is 15 over 5. So theta, give your answer in radians. Let's swap my calculator to radians. And tan inverse of 15 over 5. Tan inverse of 3 is 1.249. Question wanted the answer to 3 sig fig. So let's give the answer to 3 sig fig. Quite sneaky question, going from a bit of circle geometry to a bit of circle theorems to just normal trigonometry and Pythagoras. Question 10. It's given that, use differentiation from first principles to prove that. So clearly that differentiation holds, but we want to do it from first principles. From first principles, the formula or the rule, the definition is as so. F of f dashed is a limit as h tends to 0 of that fraction. So we need to try and simplify that fraction. Because it is a really, it is a proof question. It says prove in the question. So we do need to work relatively slowly to show all of our steps carefully. And often, well, certainly at this level, knowing how to expand out using the Pascal's triangle, the binomial coefficients very quickly is highly useful. And the sharp amongst you should have spotted I missed a bracket there. We are subtracting the whole of f(x). So let's make sure that bracket's there, otherwise we've written completely the wrong thing. And even if we recover it later, a proof style question may still penalise us for that. I'm still just in the autopilot cleaning up stage, and I've been so autopiloted that step I didn't actually do anything on. So the intent of that step was to multiply out that 5. So let's actually do that. Plus 5h cubed plus the x doesn't get multiplied and the h doesn't. And this is where the magic of this method pops in. Everything that did not have a h in ends up cancelling perfectly. So I'm left with these terms, 2 of which are useful. And now everything has a common factor of h, so I can divide through by h. And now because I no longer have a denominator of h, letting h tend to 0 with this limit causes no problems. The 15x squared is fine. That term goes to 0. That term goes to 0. And we just have a plus 1 on the end. And that's exactly what the question wanted. Careful algebra, careful that it is a proof so you can't skip too many steps. But otherwise a very comfortable 5 marks. Question 11. We have a curve which has been drawn for us. The shaded region is there. We want to show the area can be written like that. So a few different things that we need to do for this. First, we need to find the limits. So y equals 0 implies that x squared minus 8x ln x equals 0, well then that's either x equals 0, x equals 8 from the quadratic thing, or ln x equals 0. Well, if ln x equals 0, that says that x is e. No, it doesn't. Yes, 1, not e. So ln e is 1, whereas ln 1 is 0. And from the picture, we can see that that was 0, that's 1, that's 8. We're going to use the limits of 1 and 8. So that region, and actually the negative area, because it's below the x-axis, is the integral between 1 and 8 of x squared minus 8 ln x. Now, at this point, I'm starting to worry that this is a really heavy question. And if I look at the number of marks, this is a very, very heavy question. Reason being, this is going to be an integration by parts, and it's not going to be a particularly easy one. So let's set up our integration by parts. Now, if you use an acronym, LATE is very good as an acronym that tells you which to use as U first. So LATE, L is the logarithm, A is the algebra. I've got both, but log happens first. So I should let ln be U. Reason being, I can differentiate ln easily, but I can't integrate it easily. Whereas the algebra, I can integrate fairly easily. So that's a third x cubed minus 4x squared. So putting that in, I have my u v between the limits of 8 and 1, and we'll deal with that momentarily. Subtract u dash v, the integral between 8 and 1. Now u dash is 1 over x, so that just cancels out an x. Now I doubt I'll finish it on this side, but I'm going to get close. Now let's sub in our values. It's always a choice. I'm going to sub in the values here because I said I would. But we haven't done the whole integral, so you need to be careful that you are doing the right thing to the right part. I don't want to sub 8 and 1 into this thing yet because I haven't actually integrated it yet. Subbing 8 into the other section though, we're going to have a third of 8 cubed, which is 512 over 3 minus 4 lots of 8 squared. 4 lots of 8 squared is 256. Ln 8. Subtract, well, something, ln 1. But ln 1 was 0. So I don't care what that something is. So I'll write it in anyway. But it's irrelevant. It gets destroyed. I'm going to finish off simplifying that part. So 512 minus 250, 512 over 3 minus 256 gives us negative 256 over 3 ln 8. Oh, I could do even more with that, can't I? So ln 8 is ln 2 cubed, so I can bring down the cubed. Okay, so I've done just the left-hand part of this expression all the way down, but I can't forget to do the other part. So the other part I need to integrate again, increase the power, divide by the new power, and now I'm subbing in 8. 8 cubed was 512 over 9 minus 8 squared 64 minus 128. Now I need to be careful with my signs. I'm subtracting off this whole thing. So if I deal with that minus sign, I'll then add this term. And again, trusty calculator. 512 over 9 minus 128 gives negative 640, but I've got a minus sign in front of that. And then a ninth minus 2. negative 17 over 9. And I think I've just managed to fit all of this in one spot. So that's going to be 6 to... not quite. I've got one more step after this. Simplifying the numbers minus the other thing. And therefore, the area of R can be written as, noticing that this whole integral was negative R, I need to swap the signs. And I claim that is the answer. Not a very nice answer, for sure, but an answer. Now, when we get to an answer like that, there's a couple of things which we should do to check. First thing I checked, I typed R in to check that it was actually positive, and it's roughly 108. Now, because we've got our super fancy calculators, we can actually estimate this integral using the calculator. So I'm also, in my calculator, going to integrate this thing and hope that I get a very similar looking answer. So x squared minus 8x ln x between the limits of 1 and 8. And my calculator gave me an answer of negative 108.22. And the value R here that I worked out was 108.22. Of course, the sign difference, because we swapped the sign, because it's negative area. So we are almost certain, almost guaranteed with that check that we've got these 10 marks. Quite a careful calculation required there to get all the marks all the way through.